Hello all, welcome to the session. Today we are discussing about the IDEs. What's IDE? So IDE stands for Integrated Development Environment. So this is a combination of tools like a test editor, compiler, linker, debugger, etc. are available in a one roof that is called IDE. As you know, when you develop application in embedded domain, so we write the program and compile, and finally it is dumping to the development mode. So what is the process? It is taking place from user side to application running. So that are the things we are going to see now. So when you develop application, the first thing that we are doing is coding. Coding is nothing but writing the commands or instruction, and then it is going to building. So building process is nothing but the compilation. So you are already experienced when you do the C programming. After coding, you are going to building. While building, if the compiler found any errors, that will be notified. The user has to correct. Then again, this process will be repeated till it is error free. So once it is error free, generated the output binary, so we can do the debugging. So in the hardware, you can dump the code and start debugging. So we have another possibility for debugging is simulator. There are tools for simulating the program. So these all features, it is coming under one environment, is called IDE. So let us see the program development flow. So this is a target that you are seeing. We know that the binary can be loaded into the code memory of this microcontroller. So it is toggling LED. The program is running. How it is running? So somebody has to write the program. As a user, we have to write the program in some medium. Example, C or C++. So in our case, we are going to write C program. C program is a high-level language that user can easily understand, not the machine. Only the user can understand this high-level language. That is the top level, because C programs are English-like languages. So the keywords are all in English, so we can understand easily. But the application is far away. Our microcontroller cannot understand our language. So what we need is a translation from high level language to binary. That is called compiler. So what the compiler do is, it will convert our language to machine language. So when you done the C programming, you are use CC or GCC for compiling the program. But when you see the details, compiler options, there are intermediate results also there. Now let us see some of the difference between C and embedded C in the tool perspective. So this is the one that we are already experienced, the native application. Native application means you are using the host machine and the program is you are making for the machine itself. So as a native application. That means the desktop PC resources you are using exclusively. The RAM, the display, all these things are, you are writing the program for the machine only. When you come to the microcontroller, so the things are different. There is no port for display, there is no port for keyboard. You cannot directly enter the program to the target. So we need to rely on some mechanism, that is the same host machine. So host machine, what we are doing is, we are making for target. So the PC, you are writing the code and making the binary for the target. So that is called cross compilers. So when you are doing for ARM microcontroller, the ARM compiler need to be installed to the host machine. If you are doing for some other microcontroller, that compiler need to be installed on PC. And this C programming, when you are doing with the PC environment, that is independent of hardware architecture. That means the same C program, you can run it for different architectures. So it is independent of architecture. But it is coming to the microcontroller, the same code we cannot put to the other microcontroller. So we have to study the architecture of the microcontroller, what are the pins it is used. According to that only we can write the code. And desktop application, you have many resources like huge memory and display, all these things are there. But when you are coming to the microcontroller programming, you are very poor. You don't have much memory, so the memory is limited. So we have to utilize all these resources with the care. More details will be discussed later. Now let us see what are the tools integrated with the IDE. So when you are typing some program, there should be some software to accept your instructions. So normally when you are doing with the PC environment, the C programming, we use the Nano editor or VA editor. So these two programs, it will accept our text and can be saved as a file. Normally text editor we can use for typing our instruction. So it will not do any much things other than copy, paste, cut, paste, etc. So when you are in Windows, the text editor is Notepad, but other text editors like Notepad++ and all, it is available with more features. So after editing or completing our code, the next process is to compile. The compile process can be do with a single instruction or command, GCC. In the case of C programming, when you are coming to the IDE, there are keys or buttons for editor, compilation, etc. So editor, compilation. Next it is debugger. So in this figure you can see that there is a hardware debugger. So we can dump the binary code to the microcontroller through programmer, or sometimes debugger also we can use for programming. So if you are not using any hardware debugger, directly you can make the debugger as simulator. Some of the IDEs it supports simulator, not all the IDEs. So when you are not using simulator, you can go to the debugger or programmer and dump the code to your target board. So this is the total tools available with the IDE. So we have editor, compiler, debugger, programmer, simulator. But some of the IDEs having more than these features. We are going to discuss about two IDEs. One is Keel IDE, that is from ARM itself. Second one is Cube IDE, that is from ST Microelectronics. These are the popular IDEs: IAR systems, Eclipse. Keel version 5 you can freely download from the Keel website. The evaluation version limited to 32K. Beyond that, so you have to purchase the license from ARM Keel. Embed OS is another compiler that is supported with the online. That means you can do the program with the support of online compiler. No need of installing the compiler on your machine. So the compilation and editing, all these things will be happening on the cloud. The board you can connect at your host PC and you can download like a pen drive and you can run the program. So this is another IDE from ST Microelectronics, Cube IDE. Cube IDE includes the configuration tool also. That means the user can choose the peripherals according to the requirement. It will generate automatic initialization. So that is done by this Cube IDE. So Cube IDE is dedicated for ST devices. If you want to configure for other IDEs like a Keel, so you can use CubeMX configuration tool for other IDEs as well as Cube IDE. So we are focusing only on Keel and Cube IDE in this course. So that's all from this session. The detailed discussion on Keel IDE and Cube IDE will be given separately. Thank you.